Okay, so the first example that we're going to look at is a mortgage. So mortgage is you buy a house, you get a loan. Most people can't just buy a house outright. They have to get a loan. And then you make mortgage payments for, usually it's 15 or 30 years. It just depends on how you set it up. And so let's just read this. So a monthly mortgage payment consists of an amount paid toward the principal. Principal is how much you borrowed from the bank, and the interest on the loan. It may also contain an amount for the property taxes that the mortgage holder will pay from an escrow, and the amount for insurance that protects the mortgage holder in case of a default on the loan. So it's not just your payment and your interest. They also add in an insurance payment in case you don't make a payment. The insurance company helps you make that and you don't lose your house. And then property taxes. Sometimes they'll put it all in there. So you're paying a certain amount a month and the bank takes care of your taxes and you just don't have to worry so much about it. It's just all in one lump thing, and it helps people plan and budget because you don't have to make all of these separate payments to separate people. Okay, the Wimberleys have taken a 30-year mortgage for $100,000 with an interest rate of 9% on their new home. What will be the monthly payment for the principal and interest be, and how much will the Wimberleys pay in interest over the life of the loan? So this is a little interesting because we're not going to start off with the final amount. So we are going to use, I'm looking, the present value formula, the first formula at the top. And so they borrowed $100,000. And so that's the present value right now. They're borrowing the money today. That's how much the loan is worth. And then we don't know what the payments are. That's what we're looking for. And so we're going to put in P for the payments. And then big brackets. You could do big parentheses if you prefer. 1 minus, little parentheses, 1 plus I. So actually we've got to figure out what I is first. It's not just 9%, it's that interest rate divided by, so since we're doing monthly payments, so this is, the 9% is the per year. And so they'll take that 9%, which is 0.09, and they'll divide it by 12 months to give you like a monthly interest rate. And so it comes out 0.0075. And that's the number you actually put into the formula. So you have to calculate first. I should have done that right off the bat, but sorry. And then the power is negative n, which is the total number of payments. So if they're making a payment every month for 30 years, n is going to be 30 times 12. And you'll get the total number of payments they're going to make to pay the whole thing off. So 360 total payments. And so we get a negative 360 up there. And then it's divided by I, which is that 0.0075 that we came up with in the first place. Okay, so here is what I propose. There's a couple of ways to do this. All of this is going to be one crazy number. And we can calculate all of that and then divide. Oh, you know what? Yeah, we can just do that. Let's see how that works out. So on the calculator, lots of parentheses here. So we're just going to do what's in the brackets. So I'm going to put parentheses around what's on the top and then do 1 minus parentheses. And you can just make that into 1.0075. Huh? Oh, okay. And then I'm going to put all of that top in parentheses and then divide by 0.0075. And you're going to get this number. which I hope is right.
Right, yeah.
So we have 100,000 equals P times approximately 124.28, blah, blah, blah. And if you keep this number on your calculator, you won't have to worry about rounding error stuff. So what we want to do is keep that on our calculator and then take 100,000 divided by the answer. And you get that by doing the second key, and then answer is way down here at the bottom of the negative key. And it'll look like this, 100,000 divided by the answer. And we get, because I'm just solving for P, so we divide by 124.28, that number that we had on the calculator. But I didn't round it off too much because then that would make a little rounding error. And so the payments are going to be $804.62 each. And since it's a little bit more than 62 cents, occasionally they'll make your payment 63 cents, or they'll add a little extra to the end. Thank you. Okay, so does that make sense? So that's how we found A. That's how we figured the payments. And then on part B, it asks, how much will the Wimberleys pay in interest over the life of the loan? So what you do is you want to figure out how much they're actually going to pay. So they're going to make this payment 360 times. So if you multiply that on your calculator, you find out that they are actually going to pay $289,663.20 over those 30 years.
Wow.
Now, how much did they actually borrow? 100,000. And so that means they are paying $189,663.20 in interest. Now, I will say 9% interest is pretty high, but typically if you do your loan over 30 years, which some people just can't afford to do anything else, that's just what you do, so you can afford to buy the house, you usually end up paying at least twice what you owe on the house. With an interest rate this high, they almost paid 3 times what the house was worth. And that's just because you had to borrow the money and you're taking a really long time to pay it back, and so that's how it works. Most people, if you didn't have the 100,000 up front, and this is why you want to have a down payment, and most banks make sure you pay part of it in the beginning. Like you pay part of the loan and then you borrow just part of it. If you can, that's the best way to go. Okay, so let's take a look at number 2. And it's a little different situation. When Jim Baldini, I love that name, started his first job after he finished college, I'm just imagining him being this bald guy. A bald Italian guy. I don't know why. Baldini. Or he's like a circus. That sounds like a circus guy. Started his job after he finished college. He opened an individual retirement account, an IRA. He plans to contribute $2,500 per year for 38 years until he reaches age 62. So he's aiming for that early retirement. He hopes to earn an average, I'm sorry, this got cut off a little bit. This is supposed to be APR of 8% over the 38-year period. So instead of borrowing money, he's setting aside money for himself. But the formulas work pretty well the same. And so if Mr. Baldini contributes to his IRA at the rate that he plans, see how much will his account be worth when he is 62 years old. So we are now peering into the future when Mr. Baldini will be 62. So that's when we're going to use the future value formula. So I'm going to use the FN formula, and we're actually looking for the total future value, and we know how much he's going to pay. So how much is he paying per year? $2,500. So that's the payments, and that's yearly. And so he must just be, I don't know if he's just sticking a lump sum $2,500 in on January 1st every year, but in general he's putting in $2,500. And so that's the P. And then big brackets, parentheses, and I'm looking at the formula. Okay, so we've got to calculate. Oh, he's only making one payment per year. So if we do I on this, it's 0.08 divided by 1. So you actually do get to use 0.08 this time because he's only making one payment per year. Sorry, I had to convince myself why in my notes from last year it was just 0.08. So I'd have 1 plus 0.08 and so it's going to be 38 years. So we're going to use 38 up here for payments. He's going to make 38 payments. So N is 38 because it's one time per year for 38 years. And so that goes there. And then minus 1. And then over 0.08. So theoretically, if we were really good, we could type all of this into our calculators. So let's see how good we are. It's lots of parentheses. So you start with the 2,500, and then do a parentheses for the bracket, and then you have to do parentheses for the top of the fraction. And then you have to do the parentheses for the parentheses. 1 plus 0.08. Or you could have just changed that to 1.08, and then I could have left that off. To the 38 minus 1. Close the parentheses for the top of the fraction. Divide by 0.08. Close the parentheses for the bottom of the bracket. So I think I did that right. We'll find out. And then we get this. So the future value, that's a lot of money. So $550,789.86. You got to get those pennies. You might need them. So I just put in a 5, or I meant to put a 0. So copy that off our calculator. And so that's the future value of his individual retirement account. Now it says how much interest will be earned on the account. So we got to figure out how much he actually paid in. So he's paying $2,500 a year for 38 years. So we multiply that, and we find out, yeah, he paid in $95,000. That's not a bad return. So then if we subtract what he's going to get out of it, or subtract what he paid in from what he gets out, is what I meant to say, you find out that he's making $455,789.86. And you do not get that as a lump sum, then they would set up a payment plan. You have to figure out, you know, how many payments you want to get and divide it over the length of your lifespan, which is where some people are getting in trouble because people live forever now, and they sometimes run out. Okay, so really quickly, let's look at this one. When Rita Gomez started her first job after she finished college, she opened an IRA, so like what we were just doing. She plans to contribute $2,200 per year for 40 years until she reaches age 62. She hopes to earn an average of 8% a year over the 40-year period. I guess I really could do this as a practice page and just let you guys try it. Or we could just do it. What do you think? Just do it? Okay. So it says if she contributes to her IRA at the rate that she plans, how much will her account be worth when she is 63 years old? So it sets up just like the last one did. She's paying $2,200 a year. And she's doing it per year. So that means that her interest rate's 0.08 divided by 1. And so it just ends up being 0.08. So it depends on whether you're making monthly payments, quarterly payments. You just have to divide that out. And then she is making payments for 40 years at one time per year. So N is just 40. So 1 plus 0.08 to the 40 minus 1 over 0.08. And if you type all that into your calculator, you get $569,924.34 that she will get out of that IRA. It's kind of exciting. How much interest will be earned? So she's paying for 40 years at $2,200 a year. So that means she pays, 40, I wrote 4. So if you work that out, she will pay in $8,800, and then if you subtract that 88,000. If you subtract that from this number, you find out that she earned $481,924.34. Okay, that's it.
Knowledge isn't something